Hi everybody, here we're going to go over the instructions for the RC Circuit Lab. So let's go ahead and take a look at the setup. So you have the instructions here. So you have values that you're going to set the different components to. So make sure you read the instructions. And so there's part 1 and part 2. But if you look at part 1 and compare it to part 2, it's the same general outline. So you're just going to be doing two versions of a similar experiment. So let's go ahead and take a look at the computer simulation. So if you click on the computer simulation link, this is the website that's going to show up. So what you have here is a resistor. So if you click on the resistor, you can set the resistance. So you'll read the instructions to see what value you're going to set the resistance to. And you can also click on this capacitor and you'll set the capacitor to a specific value. And you can also adjust the power supply voltage. Next, there's a switch. So when you close the switch, you can run the circuit. And you can open the switch and then the current will stop running. And you can also remove the battery from the power supply. So for part 1, what you're going to do is you're going to include the battery in the circuit. You're going to record the values for the power supply, the resistor, the capacitor. So if you go to the to the Excel file, you'll start off by recording a value for the power supply, the resistor, and the capacitor. And then so here you're given at an interval of every 0.1 seconds, you're going to record the voltage displayed over the capacitor. So you'll close the switch, and so you can see here, you'll have to wait every 0.1 seconds, and at 0.1 seconds, you're going to record the voltage drop across the capacitor, and you'll wait another 0.1 seconds, and you're going to record that voltage drop. And you'll complete this table over here. So you're just going to be recording a voltage every 0.1 seconds in the first case when you're charging the capacitor. And after that, what you're going to do is you're going to make a graph of this voltage versus time data, and then you're going to enter that over here in this cell. In this region here for graph in section 8. And next, what you'll do is you're going to make a plot of voltage versus on the vertical axis, time on the horizontal axis, and you should, based on that graph, you're going to get a non-linear graph. And you're going to have to decide whether that graph is going to be an exponential, a power, or a quadratic. And once you decide what the shape of that graph is, then you're going to go over here to section, it's highlighted in red here, column V, row 22. And you're going to select your option. Is it a power? Is it an exponential? Is it a natural log? Or is it a logarithmic relationship? So you'll have to decide, well, actually, is it an exponential, a power, or a power of 2? So you have to decide which one of these options here is going to linearize the data that you see here. So up here, you have a reference, again. So if the graph is quadratic, you'll select x squared. If the graph looks like it's exponential, you'll select natural log. And if the graph is looks like it's power, then you'll select log to linearize the data. So that's the option that's given here. So based on the way that the graph looks here, you'll select either power of 2, natural log, or log to linearize the graph that you see here. So once you've done that, so there's a couple more things here. So you're going to also record the theoretical time constant for this graph. So you have to go up here and you look at, you're going to use these reference equations in order to decide to calculate the theoretical time constant. And you are also going to calculate TC. TC, that's the effective time to charge the circuit. And the equation is given over here for you. So you'll calculate the theoretical time constant in section 7. You'll calculate the effective time to charge the circuit. And then based on the data that you have in graph 8 here, you're going to select which form here should linearize the voltage versus time data. So once you've done that, you'll do your calculations and you'll enter those calculations here. So for example, if I chose V squared, so you'll have to follow this operation here. So it'll be this voltage. So let's say this voltage is 3. It'll be this voltage minus the power supply voltage raised to the power of 2. And that's what you're going to calculate here. So I already have some numbers set up here. These are just numbers that I made up. So once you've gotten the linearized data, then in section number 9 here, you're going to graph the linearized information. And once you do, you're going to plot the linearized vertical axis versus the linearized horizontal axis. In this case here, this should give you a straight line. And that straight line, you'll record the slope over here. So you're going to record the slope. And from that slope, you're going to calculate the experimental time constant. And if you go to your reference formulas, the formula is given here for you. So that's going to be 1 over the slope. And then you'll complete the part 1 of this experiment by calculating the percent error between the theoretical time constant and the experimental time constant here. And also you're going to calculate the error in the time constant using this formula. So that's going to be part 1. So what you're doing is you're charging the circuit. So you can see you're charging the circuit, and then you're going to be measuring. So let me just kind of redo this one here. So you're charging the circuit, and you're measuring how the voltage, this value here, at an interval of every 0.1 seconds. You're going to record that, and from that you're going to obtain a linearized graph that's going to help you calculate the time constant of the circuit. So that's going to be part 1. So part 2, notice that here, once you do the experiment, don't change any settings, because what you do for part 2 is you're going to just, so let's say that this is part 1 here, so you complete the experiment, the circuit is fully charged. Before you finish part 1, open up the circuit and don't change any of the settings. Otherwise, you may have to redo the experiment. So once you've completed part 1, you'll open up the circuit, and to begin part 2, you're going to remove the power supply from the circuit. And once you do, you're going to close the switch, and then once again, every 0.1 seconds, you're going to record the corresponding power supply voltage across the capacitor. So let's go ahead and take a look at that here. So for part 2, it's a similar setup. You're going to record the power supply voltage, the resistance, the capacitor, and these values should stay the same as in part 1. And you're going to, in this case here, you're discharging the circuit. So every 0.1 seconds, you're going to measure the voltage drop across the capacitor. So every 0.1 seconds, so I'm going to take a little bit to get there. So every, let's give it a second. So about your 0.1 seconds is about 0.2, look like 0.21 seconds. So this will be 0.21. And you'll have to do that for the rest of this table here. And once you've done that, just like with part 1, you're going to plot voltage versus time over here. Actually for, yes, that's right, over here. This is going to be the non-linear graph in section 8. And based on the shape of the graph, you'll decide whether this is an exponential relation, a quadratic, or a power relation. And then based on the shape that you see in the nonlinear graph, you'll decide whether you're going to use x squared or natural log or a log to linearize that graph. So once you've decided what form the information should take, or what's the form of the graph, then you'll go over here and you'll select the proper form to linearize that graph. And you also calculate, just like before, the theoretical time constant using the resistance and capacitance here to calculate the theoretical time constant, and also the time to charge the circuit. And once you set up the first row of this table, then these other data points here, so based on whatever your choice here, so again I chose x squared, so let's say that the voltage was 3 here, so then that means that all these values here have to be squared. So this will be 9 and onwards, so you'll square all these numbers. So once you've gotten these linearized data points for section 12, then you're going to create a plot of this linearized data, and you're going to insert that over here in section 14. And based, well, here this should be a straight line, and from that straight line you're going to get a slope, and you'll record that slope over here. And just like before, you're getting the slope. Based on the slope, you calculate the experimental time constant, and you'll take a percent difference between the experimental time constant and the theoretical time constant. And then after that, that should complete the experiment for the RC circuit.